So let's begin with a discussion of the frequently made mistakes from assignment 4. First and foremost, make sure that you document your code thoroughly. As always, there's a high correlation between people who document their code and people who write good code. People who don't document their code tend to write sloppy code, which is full of bugs. Speaking of which, people did a lot better on this assignment, so good job. It looks like most people put a lot of time and effort into addressing my comments and looking at the video from assignment 3 to improve the assignment 4 submission. There are some of you who still are really struggling. Oddly enough, the people who are struggling never seem to come to office hours, and so I'm not really sure how to help you, but make sure that you avail yourself of the many resources we have in the course to get the assistance you need to do well. There's really no good reason why people shouldn't be doing well on these assignments, because we have lots of opportunities to give you assistance to make your code work. So let's start talking about some of the problems. Actually, some of these things weren't necessarily problems. They were simply things where people were not doing things as effectively as they could be doing. So if you take a look here, you'll see that some people are still using the get method on scoped array and then adding in the size to that get method's result, which is doing basically pointer arithmetic. That's not incorrect. It's just not as elegant as it could be. And so once you've got your iterators implemented for ArrayList, please go back and retrofit your implementation in order to use the ArrayList iterators as opposed to the pointer arithmetic that's explicit in the implementation shown here. And most people, I'd say probably half the people need to do that. You'll get a real good example of why iterators are so cool when you start seeing how much simpler your code becomes. Also, several people would use the STL algorithms and then they would then turn around and have a loop underneath to do exactly the same thing. I have a feeling that maybe they forgot to delete that code or something. But at any rate, make sure that you don't have redundant copying of the data. This is something that won't really show up in the test program, but obviously it's overkill and you don't need to do it that way. It's an unnecessary belt and suspenders approach to this. This was confusing to me. The person was trying to use begin and end on their scoped array, which I don't think should occur because there is no begin and end methods defined in the scoped array. So please revise this to use the ArrayList iterator. And I talk about how to do that. There's a couple different ways to do this. One is to implement the const iterator in assignment 4, because you're going to need it in assignment 5 anyway, and then go ahead and use it, and in which case the code becomes very simple. If you don't want to take the time to implement const iterator for assignment 4, then go ahead and use the trick I show in this link in Piazza where you basically cast away const. Not a good long-term solution, but it'll get you by if you don't want to take the time to integrate the const iterator into assignment 4. But please try to use your ArrayList iterators for all these different algorithm operations. Same thing here. Use the ArrayList iterator and don't have redundant looping. That's unnecessary and way too inefficient. This approach here does more work than you need to do. Don't use swap for the move constructor. Instead, use source marray release. So basically, that's the most straightforward way to transfer ownership from the parameter, the source parameter that's passed into the constructor, and transfer it to the left-hand side that you're creating here. So don't do swap, but instead do release. This code here is overkill. There's no need to clear temp. That's what's going to happen with the destructor of temp. Temp's destructor, of course, will go ahead and implicitly call the destructor of scoped array, of the marray scoped array, which will go ahead and delete the item. So you don't need to do the clear. In fact, that would be, it would distract from the beauty and the elegance of this particular approach. So moving on, the code down here is too complicated. You don't need to duplicate the implementation of your swap method. Simply call the swap method and have all that code pushed in there or put in there. please go ahead and rewatch the videos where I explain how to implement a swap method. It's very canonical. Please take a look at how you implement the assignment operator. This is the copy assignment operator, and I think you'll see again that that's very clean. It should always look the same. It should never be different for different fields or different data members that you've got in your classes. It should always look exactly the same every time. This code down here, which is implementing the move assignment operator, does too much work. So please revise that to use release and reset instead, which is very simple. It's a very canonical pattern, again, that you should get accustomed to using because it's something you'll apply over and over again. Again, make sure that you use release on source marray instead of get, because the point is you're transferring the ownership. You're transferring the ownership from the right-hand side, from source, over to the left-hand side. So make sure that you use release here. This type of code, please get in the habit of never, ever, ever allocating a naked array. There's pretty much no good reason to do it in C++, and especially in a context like this, where allocating this naked array means that when the copy algorithm is run, if an exception is thrown, that array is going to be lost forever. And so make sure that you use scoped array. That's the whole point of having a scoped array, is to do something like that, to make sure that you don't have memory leaks when exceptions are thrown. I'll set up another set of comments, and this will kind of become a little bit tedious after a while because I'll say it over and over again. Please try to get in the habit of using the iterators if possible. Now, there's some situations where you may not be able to use the iterators because you may be working on scoped array, in which case then you can't use iterators on scoped array. So using iterators is only relevant when you're working on the array list, not when you're working on scoped array. So try to get in the habit of choosing between the right things. So some cases you can use the iterators, some you can't, but try to use it wherever you can. This is a case where you should be able to use your iterators, and I think you'll see it's going to greatly clean the code up by doing it that way, because once you use the iterators, then you'll see the code gets a lot cleaner. Having to do all this pointer arithmetic stuff gets a little bit convoluted, and it's much easier if that is pushed into the iterator implementation itself. Now, there was a good question asked on the discussion forum on Piazza this morning about using scoped array inside of remove. And the question is, if you don't use the scoped array and reallocate things, aren't you running the risk of not being strongly exception safe? And the answer is you are, but as we've talked about before, for operations like remove and get and set and add and so on, you don't need to be strongly exception safe. You just need to be exception safe. You need to make sure that if an exception is thrown, memory is not leaked. But it's really overkill to try to make all those operations strongly exception safe. It makes your code impossibly inefficient. And if you take a look at STL's sequential containers that are akin to ArrayList, like vector and dec and so on, you'll see that they do not go to heroic lengths to try to do this stuff with strong exception safety guarantees. So remove in place. In other words, go ahead and use the operations to copy things and fill stuff and so on. You also should be aware that there's a method called backwards copy, and you may need to use that in some of your implementations to get the right semantics, because copy may not do it for you if you have overlapping ranges, but backwards copy will work just fine. So be aware of that, and try to be consistent. Don't sometimes use the copy algorithm, sometimes use loops. It's like switching between Portuguese and Spanish or something like that in your comments. You'll confuse people, because even though they're similar, they're not identical, and it just is better to be consistent. In fact, please keep in mind that for all the assignments from now on, whenever you can use the algorithms as opposed to using loops, especially index-based loops, please go ahead and use the STL algorithms. Wasn't really clear what this was supposed to be doing. I don't think this is going to work. if you want to use this type of syntax, you're going to have an iterator in front of marray. If you want to use the initializer syntax, then it may work. But please go ahead and watch the video that I did the other day that shows how to write the iterators. So there's a video that kind of gives a couple of different examples, and I walk through them. So feel free to take a look at that. Okay, make sure that you implement your factory methods, please. Lots of weird problems in some implementations for the iterators. Things like this. This is going to lead to infinite recursion. When people write code like this, it fills me with dread because it shows that they haven't been running the unit tests, or if they have been running the unit tests, they haven't been paying attention to why the unit tests are failing. And if your unit tests are failing and you're not coming to office hours, it's very frustrating because you really need to be getting help. There's no sense sitting around being confused. So that's why we have so many resources here to help you. But I can't help you if you don't help yourself. So this will be infinite recursion. I think this will be infinite recursion. Lots of issues like this. If you're trying to return a reference to an object, don't return this. That's a pointer, not a reference. So make sure you do the right syntax. This implementation doesn't make any sense here. This code doesn't compile. And also, a lot of people did this for some reason. They iterated through this range from 0 to offset, incrementing temp by 1. That is completely unnecessary. Just use pointer arithmetic. That's what it's there for. That's its whole purpose in life. So I think you'll find that that's much more convenient. So don't be writing loops in your iterators. That doesn't make any sense. There was a comment in an earlier version of the program, which I think I forgot to delete, saying, please try to reuse your code for your const version of your iterator with the non-const version. Don't do that. That was from a previous instructor's style. I think it's hideous. Look at this code, and this is not the fault of the person writing the code. This is just what you have to do if you want to cast away const. What a nightmare. Much better just to write the code over again. It's like incredibly short and concise, and it doesn't give you any win whatsoever to reuse that code. So, like I said, that was left over from a different aesthetic that I don't happen to share. And I don't know why anybody would want to look at code like this. It's really ugly. Again, that's not a criticism of the person writing that code. They put a lot of effort into making this work, but I think it's overkill. And also, please get in the habit of using the subscript operation as opposed to the pointer arithmetic and dereference variant of these kinds of things. Okay, so that's an overview of the frequently made mistakes. Like I said, a lot of people doing much better. Good job. That's fantastic. I think you'll find that the techniques you're picking up, hopefully, to do these relatively simple implementations will serve you well as you go further down the road in this space, because it's going to make it a lot easier to understand how to do things.